she got her degree at veterinary medicine, and he attended a PhD program at the University of Bologna. And she was not working with mice or rats, she was working there with pigs when I realized that. And in 2022, she moved to Switzerland to start her ACLM education. And currently she is the deputy head of the mouse breeding facility at the university in Bern. Great. So welcome, Camilla. Pleasure to have you here. You can now share your screen if you would like to.
Sure.
It's all yours.
Okay. Do you see my screen now? Can you hear?
Yes. Yes.
Okay. You see the presentation mode, right?
Yes, absolutely.
Properly. Okay. Okay. Good afternoon again, everyone. Thank you very much for the introduction. Today, I would like to talk you about a transgenic sterile line, which is used for reproductive techniques. And in particular, today we'll talk about the sterility assessment of black-coated males that were born in our colony that is currently ongoing at the Experimental Animal Center of Bern University. So this is the table of contents of my presentation. We will have a brief introduction of the line, why it was created, for which purposes, and how it was created. Then the objective of our small project, how we did it, so material and methods, and then the results. Lastly, we will have a slide with the preliminary conclusions. So first of all, I would like to acknowledge the father of the line, Dr. Pavel Pelczar, who is currently the head of the Center for Transgenic Models in Basel University. So this line was first published in 2010 with the first version. And now we are at the third version of this transgenic line. It is actually called a transgenic vasectomized line, and it was created by Dr. Pelczar to avoid the surgical vasectomy. Indeed, in these males, the prim protein is overexpressed, and in this way, it gets, it develops male sterility. So the males are able to mate, however, their sperm are not functional. Please note that this transgenic sterile line is publicly available. So if you would like to get some animals to establish a colony in your facility, please feel free to reach out to Dr. Pelczar. So as you can see, this is the official name of the line. It's a line on a mixed background. And you can see the construct, the transgenic construct that was inserted. So we have the PRM1-EGFP construct that determines the overexpression indeed of this protein that gives male sterility without, however, affecting the mating performance of the males. So they are able to produce plug to mate, but their sperm is not functional. Then the PRIM1 construct is linked to the CAG RFP reported, which gives a phenotypic typical M-cherry skin marker. And this is very useful because it avoids the burden of biopsies for the animals. Because as you can see from this picture, on the right side of my slide, you have the transgenic mice, which have this very pink skin and is clearly visible, and you can clearly differentiate within the other animals. Then in the line, there is also the TRC mutation that gives the agouti, and when it's recessive, homozygous, then it gives the albino coat color that also downregulates the expression of the transgene. So the males, which are agouti and with the M-cherry skin, are sterile. The line is maintained, therefore, by mating the albino males, in which the transgene is down-regulated, with agouti and cherry females, which are fertile. However, the line it is on a mixed background. Therefore, while maintaining the colony at the experimental animal center, we found black animals, so black-coated animals. And since these animals, especially the males, had the M-cherry skin, then the hypothesis also discussed with Dr. Pelczar was that they also could be sterile, should be sterile. And to promote the reduction, and so to avoid just discarding these black males, we wanted to confirm their sterility, and this is why we set up this project. So as you can see, the group that we assessed is a small number of animals, because it's really a first preliminary assessment of these black males. We had 3 males for each coat color, let's say, 3 agouti and 3 black, both with M-cherry skin, of course, and then 3 albino males. We did the genotyping of the animals and the mini-muga test to assess the inbreeding status of the colony at Bern. Then all the males were challenged in vivo with the fertile proven females. And then post-mortem, we did an in vitro analysis of the sperm, motility and morphology, and a comparative histology analysis done by the COMPAT service from VetSwiss here in Bern. To note, the genotyping was done post-mortem because of, because we didn't want to take a biopsy from live animals since they had the M-cherry skin marker. So as you can see here from the genotyping results, both groups of M-cherry males, so black-coated and agouti-coated, express the transgene, not only in a qualitative analysis, but also quantitatively, they express the transgene in a similar way, as you can see from the table. Then concerning the mini-muga that we did to estimate the inbreeding status of the colony, we were very happy to know that the colony at the experimental animal center is still outbred with an excellent quality, let's say. Then concerning the in vivo challenge, so with the fertile proven females, as expected, only the albino males were able to produce the plug and then to produce also pups, let's say, so they proven fertile. While the M-cherry albino and black males were, yes, able to produce the plugs, but never saw a litter, and the challenge was run for more than 6 weeks. Then concerning the sperm analysis, as you can see from the motility, we have the agouti males as expected, with almost all of the sperms immotile, and also for the black males, except for 1 male in which we observed a 2% of functional motile sperm, while around 12% of unfunctional motile sperms. The white albino males were as expected, with so sperm with functional motility. While concerning the morphology, again, as you can see here, the black group is somehow in between the albino, so the fertile group, and the agouti sterile group. So also the black are somehow in between. I mean, more towards the agouti, but however, they had around 20% of average normal morphology of the sperm. Then the here we have the pictures of the comparative histology done, as I said, by the COMPAT service, Dr. Christine Göpfert and Danushka Evapatirana, that provided us with the pictures. On the left, you have the seminiferous tubules, while on the right, you have the epididymal ducts for each group. So as you can see in the agouti animals, there is a severe tubular atrophy, and there are only a few residual sperms within the epididymal ducts. While for the black males, you can see that the morphological changes are, yes, present, but less severe. While on the other hand, the albino males are almost, I mean, they can be considered normal. Then here we have the comparative histology, I mean, summarized in a table, and the histopathological score is related to the normal morphology. So the higher the score, the higher the normal morphology. Again, as you can see, the black males can be considered somehow intermediate between the when compared to the albino and the agouti males. So to summarize what we can say that the M-cherry black males, they proved sterile in vivo, so they can be used as unfertile studs to produce plugs. However, in the black males, the morphofunctional parameters that we saw, they were intermediate compared to the agouti animals. So even if the transgene is similarly expressed, as we saw in one of the first results slide, the morphofunctional parameters are, I mean, slightly different from the agouti ones. So given the results that show potential risk of leaky males, and to avoid, of course, the single housing of the sterile studs, so to avoid them to be single housed in between the matings for the plug positive females production, we recommend using companion fertile females. And this is as well in accordance with Dr. Pelczar opinion. As I said before, the group, I mean, the groups that we assessed they had very few animals. So first of all, more investigation should be done. So we are planning to assess more males to rule out outliers. So maybe we just took the 3 black males that were a little bit different from the agouti ones. And also we cannot exclude that the colony that we are currently breeding at the Experimental Animal Center can be somehow consider an initial substrain from the original colony. So I would like to thank you for your attention very much. And special thanks to my colleagues in the Experimental Animal Center, Dr. Sara Fuochi, Alessandra Bergadano, Jorum Kirundi, who has a great experience in reproductive techniques, and also Carlotta De Totto. I would like to thank as well Christine Göpfer and Danushka Evapatirana, who did the histology analysis, and of course Pavel Pelczar for his very precious suggestions and opinions. I hope I was clear, and if you have any questions, please let me know.